Right. Now, do we have any questions regarding what we've covered so far? Right. So the 2 units that we've essentially covered. Because even under resulting velocity, you essentially get two cases. Right. I've covered both cases. Right. So now it's a matter of you guys doing as many exercises that you can do. Right. So are there any questions here? Have you guys attempted any of the exercises I sent in the group? I sent you an exercise, it's 2 pages on relative velocity. I also sent you an exercise, also 2 pages on resulting velocity. Right, have you attempted those questions? Hello?
Yes, I have on my side. Just one question, the nated God. I just want to ask, you said we must always take reference from the x-axis when we relate to the angle.
Yes.
I just want to know in the case whereby, because I've updated a couple of questions, when you look at the answer in terms of the direction, you feel like, maybe you've got it wrong. Is there instead whereby you have reference from the x-axis, the next thing when you come to the direction is different from the guy who has reference from the y-axis?
So the magnitude of the resulting velocity, be it relative velocity or resulting velocity, would be the same. So
Yes.
only the angle would be different, right? So for
Yes.
someone who's referenced their angles from the x-axis, their angle will be different from someone who's referenced their angle as well as direction will be different from someone who's referenced their angles from the y-axis, right? The one common
Yes.
factor though is that whether you reference your angle from the x-axis or y-axis, right, your directions will be the same from a perspective of you are going to have the same direction. So if your direction, right, if one of the directions is say north and one of the directions is east, right, the only major difference is that for the one that references their angles from the x-axis, it would be east angle north, right? And then from the for the one
Mhm.
that references their angle from the y-axis, it would be north angle east, right? Either way, though, you will both have east and north, right? It'll just be one way or the other depending on where you reference your angle, right? So you won't be wrong just because. So for test and exam purposes, we account for both angles or both directions. Have I answered your question yet?
Yes, you've answered my question. The challenge is in the examples or the question that you sent us, we only have one answer, right?
No.
In terms
Yes.
of direction. Yes, the magnitude, you find out the magnitude is the same when you calculate it. However, when you look at the direction, you find out maybe I didn't get it, or
No,
maybe
man. So say you reference your angle from the x-axis, right? And they have the same magnitude that you got, but a different angle, right? Or on the answers on that exercise. Ne?
Mhm.
All you do is you say 90 minus what you got. If you say 90 minus what you got and you get the angle that they have, it means your angle is correct. It means the answer that's on the problem is a reference from a different axis. So don't worry about that. But that's how you can check if you are correct or not. Are we clear?
All right. No,
So
I'm sorted for now.
if you if you if you check your angle like that and you still don't get the angle that they have, right? Then at that point you can either consult with me or your fellow students,
Noted.
right? Just so we are clear, some of those answers will probably be off, right? Because those are answers that I got from the marking guideline on what is this on these apps for past exam questions, right? So it will happen that maybe you do your calculation and you don't get the same answer that's on there, right? So if that's the case, you can simply alert me of that problem. I will do a solution, right, and then send in the group. Kapish?
See.
Right. Any more questions? Right. So with science, you definitely have to go through my videos, right? Definitely have to go through my videos. Try doing so with understanding. So you have to write notes. You have to write something down, right? And then, of course, attempt problems, right? When I send you exercises, you are definitely not going to escape um, having to do the work here, right? During our live sessions, not all our live sessions will I be, what is this, essentially teaching or lecturing. But some of the sessions will be like this one, where I've covered everything I feel like I needed to cover, right? Then the rest is up to you. Right. So essentially now for relative velocity and resultant velocity, it's up to you really now. I've given you n and all resources you would need to understand those two units, right? What I will do next is cover projectile motion, right? And then, of course, do what is this? Cover beams, right? Because beams will also be in your test, right? Though I'm not expecting people to struggle with beams because we've been doing beams since N2, right? The only thing that will be new under beams is bending moments, which I will explain.
Yes,
Right?
sir.
Any more questions? So, not having questions does that mean you guys everything is going all right? Everything is just smooth sailing. You are doing your tutorials or exercises, and you are getting your answers as you should. Because no questions usually means either everything is going well or everything is going horribly wrong. So which one is it for you?
For me, I think everything is going horribly wrong, but I'll catch up. Um,
Okay.
just to, in the absence of questions, just to, because I watched the second video on the, I think it was
Resulting.
on the resulted.
Yeah.
There was a question whereby you were converting from kilometers per hour to meters per second, if I'm not mistaken.
Yes.
Yes. I haven't attended the question, but uh, I don't know if it was me or I'm still rusted in terms of the conversion.
Sure.
When you convert from kilometers an hour to meters per second, do we times the minutes by 60 or do we divide the minutes by 60? I mean, hours by 60.
Right. Let's see. Can you guys see my screen?
Yes, sir.
Yes, sir.
Yes, sir.
Right. So from minutes to second, you multiply by 60. From minutes to second, you multiply by 60.
All right,
Right.
no, thanks.
So I think there it seemed like we are dividing because remember you have kilometers per hour. Right. So because you have kilometers per hour, right? So converting from meters to, let me see here. You guys can still see my screen, right?
Yes, sir.
Yes, okay.
Okay. Er, right. So, what did we have? I think it's this one. No, it's not this one. No, it's not this one. No, it is this one. Yeah, yeah, it is. It is this one. So, for
You say
instance, we had to convert our resulting velocity. Where is it? There. We had to convert our resulting velocity from kilometers per hour to kilometers per minute to kilometers per hour. Right? Right. So, meaning here, let's see, we said because this is 300 kilometers, you multiply that by 1,000. And then in terms of minutes, we had 50 minutes. So then, yeah, you say 50. So this was supposed to be 50 times, not 50 divided by. So I see the confusion here. This was supposed to be 50 times 60, right? And then if you do that, this is 300 times 10 to the 3 over 50 times 60. Right, yes. Right, so from minutes to seconds, you multiply by 60. From hour to seconds, you multiply by 3,600. Are we clear now?
yes, thank you. Thank you for your clarity.
All right, cool. Any more questions? See, this is what I'm talking about. Questions. Beautiful. Right? Here, you are not going to escape having to do the work. Got to do the work. Right? Otherwise, you won't get to understand engineering science in general. Right? It's not like having to do mechanotechnology entry where you have to just read and cram and go write your test. Right? Or read and cram the day before your test. Right? This will be very overwhelming if you're thinking that you're going to be able to do it the day before or the night before your test. Right? Bloody well done there, Chief. Right. Any more questions? Hello.
No questions on my side.
Right. It seems a lot of you don't have questions, or maybe some of you just attended the class and left because they're still busy at work, which is fine. Right. So now my suggestion to you is to go through those exercises I sent in the group. They'll be very helpful. Right. Very helpful, even for the test. Right. If you are able to do those exercises, right? If you understand how to approach those exercises, I am telling you, for the test and the exam, you'll be fine. Because essentially, what it will mean is that you understand kinematics conceptually, right? If you understand kinematics or the units under kinematics conceptually, right, hardly any problem will be a problem for you. Right? That is why,
Sorry, sir.
yes.
Um, I just want to ask one more question. I think I'm rusted. I just want to know in terms of notation, right? You said,
In terms
if I
of,
remember correct, notations like
mhm,
object and the reference, all of this stuff.
mhm,
Because I tend to confuse them in terms of if I would say velocity of O in reference to P or Q in
yeah,
reference to P. It kind of confuses me. Can you at least take me back a little bit so that I know I don't turn it around?
okay. No, that's fine. Right. This one doesn't necessarily need an exercise. Right. This one I can just simply explain. Right. Now with relative velocity, right? Relative velocity, you're essentially calculating the velocity of one object with respect to another. So compared to another, right? So if they say, for instance, calculate the velocity, you have two objects A and B, right? You have two objects A and B. They are moving at their own velocities, right? And going in their own directions. And then the question says calculate the velocity of A relative to B, right? So when they say calculate,
Sorry, sir. Are you displaying it on the screen? Because I don't see anything.
you guys can't see anything.
Yeah, I don't.
No, I can't see anything. It's just stripes.
Just stripes.
Yeah, like just the clean.
So I had not written anything. Can you see something now?
Yes, we can. We can.
So calculate. I had not written anything yet. So calculate the velocity of, say, A relative to B, right? So essentially calculate the velocity of object A relative to B, right? They could also phrase it as calculate the velocity of A with respect to B, right? So they could use any word that is essentially a synonym to relative, right? So calculate the velocity of A relative to B, right? So essentially in this question, you want to calculate the velocity of A, right? So A is the object that you're calculating compared to what? Compared to B, right? So the velocity that you're calculating, right? You take that velocity as the velocity of the object, right? So seeing that you want to calculate the velocity of A, it means A for this one is our object, right? And then the velocity it is being compared to, so relative to B, right? It means B will be our frame of reference, right? So essentially for this one, A is the object, right? And B is our frame of reference, right? Now, how do we put that? Mathematically, when they say calculate the velocity of A being the object relative to B being the frame of reference, it means essentially you are calculating V. A is the object, B is the frame of reference. Right. So the first letter is the object, second letter is frame of reference. Right. Another way they can write this is by saying A, V, B. Right. Again, first letter is the object, second letter is frame of reference. Right. So that is to say, when they say now calculates the velocity, right? Say now they say calculate the velocity of B relative to A, right? Again, you look at which velocity you are trying to calculate. You want to calculate the velocity of B. So B for this one is the object compared to A, so relative to A, meaning A for this one is the frame of reference. So for this one in particular, B would be the object, A would be the frame of reference. All right. So meaning mathematically this would be V, B, A, or B, V, A. Right. So first letter, object. So the object here is object B, and A is the frame of reference, A being the second letter. Or if you write it like this, again, the first letter is your object, right? And then A being the second letter is our frame of reference. Right, so that's how you look at it. Are we clear?
Yes, it's clear, sir.
So I don't know if that was the same person that asked the question. I think Mzugisi. Mzugisi, are we clear, your chief? Mzugisi is quiet now.
Sorry, say I lost connectivity.
You
But
lost
I
connectivity.
I grasped it. I think
Okay.
I saw it.
Okay.
But just to add on it, I see with A and B, it's clear. In the case whereby we're using the method of components and you're trying to find a Y or X component,
Yes.
in the where they give you point A, point Y, and point X. I think at some point I wrote a very crazy formula there.
Let's see. Uh,
I apologize for my connectivity. It seems to be bad.
it's okay, man. Right. Say you have. Say that is object A. Say that's A. We'll just call it A. No, we can't call it A. Let us call it.
Called
Okay.
Y and X. Let's use Y and X.
Remember, we have to use that for our components. Right. So let's call this object A. Okay, I'll
Sorry,
write it.
sir.
Yes.
Sorry, sir. Because there are questions whereby they give you, let's say, a moving vehicle Y or X. So I want to see when you have those, because I know when you use the method of components, you need to find the X component and the Y component. But at the very same time, they noted the moving vehicles or the object and the frame of reference as Y and X.
Right. So you have a moving object Y, right? So in that case, do they give you the magnitude?
Yes, they
Do
don't
they
give you
give
the
you the
magnitude of
velocity?
Y. Yes.
Right. So if they give you the what is this? If they give you the magnitude of Y, say Y is equal to what? Give me a number there.
100. Say 100.
Kilometers per hour.
Yes.
All right. So they said Y. So Y is equal to 100 kilometers per hour, right? It is going in that direction, for instance. And then you have an object X. Object X is, say, moving in this direction, right? Object X is moving in this direction, right? Object X is, say, X is equal to, give me a number there,
Say 50 kilometers an hour.
50 kilometers per hour, right? Now, as far as angles, our angles being referenced from the x-axis or y-axis, or it doesn't matter.
It doesn't matter.
Okay, let us reference our angles from the x-axis. Right, so let's say this is 30 degrees, and say this one is making an angle of, say, 60 degrees, right? Now, when resolving this, you're going to have a vertical component as well as horizontal component, right? So a vertical component, this will be, say, Vx, not Vx, so Vx sine theta, which is 60, right? And this one would be Vx in the y direction. So Vx cos 60 degrees, right? So essentially, this will be equal to 50 sine 60, and this will be equal to 50 cos 60. And this here would be equal to, let's move this a bit, right? So this one would be equal to So this one being the vertical component, this being the horizontal component. Horizontal component would be, let's say, Vy cos 30. This one would be being the vertical component, Vy sine, not sine 60, sine 30. So essentially this would be 100 sine 30, and this one would be 100 cos 30. Right. So in writing or in applying our conditions of equilibrium, this would be sine of v in the x direction. Right. Now, are we looking for between y and x, which one is the object?
Let's make X an object.
So this would be v in the x direction, x, y is equal to x, what's this thing, vx. So vx. So vx is this one. This is horizontal, so this would be vx cos 60. So this will be vx cos 60, right, plus vy cos 30. Right, then you do your substitution, right? Or if this is confusing for you, what you can do is you would then, instead of writing it like this, right, if it's too confusing, you can simply say the sum of x v y in the x direction is equal to, then write this, right, so as to separate the two x's, right? And then as far as the sum of vy, this will be sum of v in the y direction, right? X is the object, so this will be x, y is the frame of reference. This will be equal to v x first in the y direction, which is sine 30. So vx sine 30 plus vy sine, what is this? Sine, wait, x. So x is 30. I mean, x is 60. This is supposed to be 60. And then vy, y is sine 30, right? And then, of course, make your substitution, right? But this is the attempt you would take then.
All right.
Or if it's still confusing, you can ignore this, right? Ignore this and just use that, right? Marks wouldn't be deducted for having left that part out, as long as you understand what this is for, right? So meaning once you've calculated your sum of v in the x direction and calculated your sum having left this out, right? So essentially this is what you'd have, right? So if you decide to leave the object and frame of reference in your calculation, right, the most important thing you would then have to do is when calculating the, using Pythagoras to calculate the resultant, then you would say v x y is equal to the square root of the sum of vx squared plus the sum of vy squared, right? This here is the most important anyway. Are we clear?
Yeah, it's clear now.
All right. Any more
So
questions?
can you also
Very good
can you
questions.
write out the words in, can you like
Second,
write out the words like vertical and horizontal?
you can do that as well, right? So here it doesn't matter
Okay.
actually how you approach this. You can say horizontal component, you can say vertical component, right? Mathematically, as long as this is what you have, right? So when you say horizontal component, because remember this is the horizontal component of the what, of the resultant anyway. So if you use your words, that's fine, right? Again, the most important thing here is getting this one correctly. I will clear you.
Yes, sir.
Loud and clear, sir. Um,
Right.
in absence of other questions, like I said, I'm rusted. So in this one is with regards to the resultant velocity.
Yes.
I don't know, it was in the first video or in the second video where you were calculating a resultant for a plane that was supposed to, after a certain distance, it must be at
Second video.
a certain direction.
Yes.
Then I don't think we were given a wind, or I don't know what a wind direction. I don't know if you made an assumption there, or practically it was supposed to be like that. How do you get another that other direction?
Right.
I don't
So there
remember.
you would the direction of the wind vector was northeastern.
Yes,
Right. So northeastern. Right. Now when you are given directions like this one, right, northeastern, northwestern, southwestern, southeastern, right, you always assume that if you think of the Cartesian plane, right, if you think of the Cartesian plane, right, when they say a vector is northeastern, right, northeastern would be in the first quadrant, right. If you think about it, right, you would think that that would be in the middle, right, of what, between east and north, right. Hence, this angle would be what? Would be 45 degrees, right? If you think about it. Do you see what I'm saying? Right?
yes, yes,
Northeast, right, is essentially at the middle of this quadrant. So between north and east, right? And the middle of a quadrant, right, from the perspective of the angle, will always be at 45 degrees. Right? So when they say your vector is northeast, right? Essentially what they're saying is that the angle, essentially they are telling you the angle where your vector is referenced from. Right? So when they say north, it means your angle is referenced from north, 45 degrees, 45 degrees east. Right? And of course, knowing that this is 45 degrees, right, it means the angle reference from the x-axis is also 45 degrees. Right? But that is how you look at an angle that is in terms of either northeastern or northeast, northwest, southwest, southeast. Right? So you always assume the angle is 45 degrees. I will clear you.
yes. We're clear on that one, sir. I think my question was is a bit that I'm trying to get this question. Give you the exact, because I know the direction of the plane that original it was supposed to take off like northeastern. You have the distance on the x-axis that it was going to the east.
Yeah.
So the wind was blowing in a certain direction. Then you assume that, I think if I'm not mistaken, on that video you had this wind direction, or I don't know. Can I see? I'll tell you which one is it, because I'm trying to find on my book where did I get that question.
I think it's this one.
There we go. I think this is the one.
Yeah.
You only had the resultant, you were given the distance was so much, then you had
Yes.
the wind, but you needed direction of the plane, if I'm not
Yes.
mistaken. But you didn't have, you it was not given, if I'm not mistaken.
So what was not given? Because what is not given here is the original velocity of the aeroplane, which is
Original
what is given.
velocity, yes.
Right. So
How
what
did
is
you
the
get
question?
no,
Uh,
how do you get to say that the original velocity will be in that quadrant? That's what I wanted to know, because I know.
right. Right. Now, we have been told that our aeroplane, after flying 300 kilometers, must end up directly west. Right. And
Yes,
we've been given the wind vector, where the wind is going. Right. So we haven't been
yes,
given the direction of the aeroplane. Right. We also haven't been given
yes,
the original velocity of the aeroplane. Right. So you then have to think about it practically. Right. you want to end up going east, right? There is this wind vector that is blowing northwest, or that is blowing in a northeastern direction, right? So if you think about it practically, you want to end up going in a direction directly east. You want to end up east after flying for 50 minutes or after 300 kilometers, right? Do you fly the plane east? Do you fly the plane? Do you take off and fly the plane directly east, right? If you do that, when the plane flies directly east, right, this wind vector, right, will essentially push the plane in that direction, right? So we are thinking about it practically now, right? That if you take off and fly the plane directly east, right, because there is a wind that is in a northwestern direction, right, it is going to tend to want to take the plane in a northwestern direction. So in that direction, right? So meaning we cannot fly the plane directly east. Why? Because this wind vector will blow the plane off course, right? Hence, after 300 kilometers or after 50 minutes, you're gonna end up somewhere in this quadrant, right? Which is not the intended direction, right? So you now think, how do I get my plane to end up directly east after 300 kilometers, right? So the only explanation is you fly your plane in this direction, right? So you essentially counter the wind, right? So as to end up directly east after 50 minutes or after 300 kilometers, right? So you fly your aeroplane in this direction, right? Counteracting the wind, because the wind, is going to push you in this direction, right? So when it pushes you in this direction, right, you will have flown the plane such that when the wind vector pushes you in this direction, right, it is essentially going to place you directly east after 50 minutes or after 300 kilometers.
Ah, it's clear. It's clear, sir. I wanted to understand. I can see practicality
Yeah. So
applied here. Okay,
yes,
it's not an assumption.
you
Okay,
would have to look at it practically, right? You would have to look at it
okay.
practically. No?
No, I think I'm good for the day. It's too much information.
All right. Beautiful, beautiful questions. Thanks, my guy.
Thank you.
Any more questions? What the hell?
Sorry, sir. On the first study pack that you've sent,
Yes.
I think this is a question paper for the 2020 April, and that is 3.1.
Okay.
I got stuck there because my understanding has always been that velocity is equal to displacement over time.
Yes.
So when I look at the memo, I see there's cos theta there. I didn't know where that formula they've used there. Where did they take from? Because when I check on the on the on the formula sheet, I didn't see that formula. I don't think
Uh,
it's that one, sir. It's not that one. The very first study pack you've sent.
Study pack. Okay.
Yes, it has the exams starting from 2020 April.
Right. So this one.
Yes.
So what's the question here? Is your question based
Question
on April
3.1.
2020 or question 3.1?
Yes, 3.1, yeah.
3.1.
Yes.
Okay, there.
Yes.
Okay, so 3.1. So you have done, let me see, because 3.1 is based on projectile motion. Are you on projectile motion already?
No. No, but I thought I should do it, but yeah, I
Okay,
didn't
so
realize we are not there yet.
no, we haven't covered this yet. So first, let me do a video on this, right? Maybe the video will give you
Okay.
enough clarity to answer whatever
Mm.
question you have regarding this question. Right? But this is projectile motion, right? So
Yeah, okay.
projectile
See,
motion, projectile motion is different from resulting and relative velocity. right?
Yeah.
Because with projection motion, we essentially use what is this? Kinematic equations. What do they call it? What's the other
Okay.
word for kinematic equations? Equations of motion. Yeah, I think that's the more popular term. Right. So for projection motion, we essentially just use equations of motion. Right.
Okay.
Yeah. I'll likely do a video on it tomorrow, right, and post in upload in the group, right, and then I'll decide if we'll have a session on Friday, or maybe we can have another session on what is this Sunday, and then another one on Monday before your test on Tuesday.
Yes, because I was gonna ask, seeing that the time is ticking, I was gonna ask the other two units when are we gonna cover them because
I
there's no
remember
time.
under kinematics, we're just left with projectile motion. Right, projectile motion will be a walk in the park. I promise you that. Right, and then you'll be left with beams. Right, and for beams, I'm not expecting people to struggle with beams, because essentially from the beams that you've been doing from N2, right, only one section hasn't been covered. That's bending moments, which I will cover thoroughly.
But say some of us don't have N2, eh?
Some of you don't have N2. Okay, it's fine. Do you have N3?
Yes. No.
Some of us are from electrical.
Some of
We
you are
jumped
from
the steps.
electrical. Some of you are from electrical. How are
We
you
jumped the
expecting
steps.
that?
It's for
Oh,
GCC purposes.
GCC purposes.
Yes, sir.
Yeah, I've
Yes.
also started in N4, so I also don't have N2 and N3.
Okay. Um. Okay.
Same
Either way,
A
though.
lot.
Either way, I think I'm pretty decent at this explaining thing. Right? Beams will be a walk, should be a walk in the park, or I'll try my best for them to be a walk in the park. Right?
Okay.
Another question is, sorry, I just want to find out the way you calculate this velocity is on the exam is strictly the way it's supposed to be calculated, or can I use the parallelogram method or this one?
All right. So you
Because I
can
think
use
I'm more comfortable with
parallelogram.
the parallelogram. Yes.
Yeah, the parallelogram is easier, but I see, or I noticed most of the students prefer the method of components because resolving is what they're used to, right? But to answer your question, you can use any method, right? Unless it's been specified in the question to either use the method of components or the velocity diagram or vector diagram, right? But it is important that you are comfortable with both, because you never know what the examiner is going to ask you, right?
All right. Thank you, sir.
But generally, you can use any, right? Any more questions? Right. So there is a video on beams already, right? In my channel. It's a matter of just sending you the link to that video, right? But before sending you that video, I want to first, or maybe I'll just send you the video, right? You can use your own discretion. You can go through it while you are going through what is this projectile motion, right? So I'll send you the link. It's fine, because I see some of you are worried about beams, and also if you did electrical, I would understand. I'd understand why you would be worried about beams, because essentially you've never done beams, right?
That's correct, sir.
All right. So I'll send you the link today for beams, right? I will be doing more videos on beams because I think I've only uploaded one video on beams. I've never done another one, right? So for now, though, the video or the link that I will send you should suffice for now, right? And then over the weekend, I'll be uploading more videos, probably two more videos, right? Before we have the session, right? But by Monday, Right. Monday we should have a session, say maybe around 3, right? So as to give you enough time to look at your books after the session, right? So as to make sure that you're well prepared for test 1, right? But just so we are clear, right? The documents I sent you in the group, right? If you're able to do those problems, I'm telling you, you'll be fine for the test. So use those. Are we clear here?
Yes, sir.
Yes, sir.
Yes, sir.
Right? That is all I'm saying. Use those, people. Are we clear here?
100%,
Yes,
sir.
sir. Yes, sir. You are clear. You are clear.
Okay.
Yeah,
That's
meneer. Ja, meneer.
Yeah,
okay.
yeah, we're good.
Right. So any more questions? No more questions.
Does that go for the projectiles video you're gonna put up as well, sir?
Yeah, the projectile video I'm gonna do tomorrow. I should upload it tomorrow, and then I'll send you the link to that video.
Okay.
Right.
Just last question. When can we expect the communication for the session that we'll have on the weekend, so that I can actually squeeze it in to make sure that I'm comfortable where I am to listen over the session.
All right. I'll either communicate on Thursday. Today's Wednesday, so either tomorrow or Friday. Yeah, either tomorrow or Friday. I don't know if people are comfortable with having the session on Sunday. I think by then I will have uploaded all the videos I need to have uploaded. Right. So this is projectile motion and beams. Are people fine with Sunday?
I'm comfortable with Sunday, say, but only if it's gonna start after 3 because I'm working this weekend.
Okay, how
I'm
about
working 7.
Saturday? No, Saturday, there's no way. I don't want to take risks for Saturday. But what are you
So,
comfortable with? Saturday or
some
Sunday?
of us are writing on Monday.
On Monday? Ah,
Yes.
yes. Damn.
Oh, sorry. On the 17th, yeah, on the 17th, we are writing.
I forgot. I forgot that Monday
Yeah.
is a holiday for you. Uh, okay. Are any of you writing at 6 p.m. on Monday?
No, I'm not sure because I'm writing on around 9.
So, will everyone who's writing on Monday be done writing by 3 p.m. on Monday? Okay, so it seems like it's only you. So we should be fine, right? We can have a class, say, around 3, right? We will talk about this again during the session we'll have over the weekend. So as to confirm what time you guys are comfortable with for the Monday session.
Yep.
We good?
Yes, that's good.
All right. I think we can end the session here for now, right? And then we'll have another one over the weekend.
Thank you.
And another one
Thank
on Monday,
you.
just before the test on Tuesday. Right. All right, people. I feel like this was a good session. I got very good questions. Very good questions you had. Right. It shows people are going through the videos, right, which I like very much. Bloody well done. And yeah, good luck with your subjects. Good luck with studying. I'm available for questions. Right. Also speak amongst each other. Right. Help each other out as much as possible. Right. All right.
Thank you.
Have a good evening, guys.
Thank you very much, sir. Same to you.
Thank
Thank you,
you.
sir.
Bye.
Thank you, sir.
Bye.
Bye.
Thank you. Bye.
Cheers. Go and take a piece.